Indexes are enormously important in any database. With the right indexes in place, MongoDB can use its hardware efficiently and serve your application's queries quickly. But the wrong indexes produce the opposite result. That is, slow queries, slow read and write operations, and poorly utilized hardware. Indexes are the root to high performance in MongoDB, and you can even make them faster by querying those fields that are already indexed. That's where we use covered queries. On that note, hey everyone, welcome to SimpliCode's YouTube channel. I hope you guys are doing good and staying safe. Before we begin, I hope my audio is also fine and the screen is clearly visible to you guys. If you're facing any issues, let us know in the chat section below and we'll try to resolve it as soon as possible. Well, coming to today's topic, in today's session, we'll look at how to use covered queries and analyze those covered queries and the performance that it creates while you query a MongoDB database. So which helps us to query data more quickly. So without any further ado, let's get started. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. Alright, now what are covered queries? Now we know that in every database including MongoDB, indexes play a crucial role. MongoDB queries are executed more quickly when indexes are used. As you know, we have discussed in our previous tutorials on MongoDB indexing. So if you haven't checked that out, make sure you check that out on our channel. We have a dedicated playlist on various MongoDB concepts as well, wherein we have covered MongoDB indexing as well. So you make sure you check that out. Now, indexes basically provide users with an efficient way of querying data. So if you ran a query to find specific documents, let's say in a collection of thousands or lakhs of documents without any indexes, MongoDB would have to search the entire collection in order to find the requested document in your query. However, MongoDB would use indexes if you had them to reduce the number of documents that needed to be searched in the collection. Now, there is an additional, part of indexing, that is covered queries. So you've probably heard that column indexing is an excellent way to improve query performance by reducing the number of disk access that are required. Now, covered queries is basically a MongoDB-specific application of field indexing in which all the query columns are already indexed. Now, it basically avoids collection scan just like the normal indexing. So it allows the database to search through less document to satisfy a query. Without an index, MongoDB has to scan through all the documents to ensure it has answered the query correctly. Now, covered queries are extremely fast because MongoDB does not have to examine any other documents other than the ones that have been indexed. So it only examines document in your query that you have provided the indexing, that you have provided the fields that are already indexed. And finally, fetching data becomes much faster using covered queries because covered queries return results from an index directly without having to access the source document and are therefore very efficient as well. Now, there are cases when you have to consider when to use covered queries. Now, covered queries are only used when all the fields in a query are part of the index. So, let's say if you're trying to find any field in your query, it should be a part of index that you have already created. Only then covered queries can come into picture or can be used in a more efficient way. Next is all the fields returned in the query should be are in the same index. Now it can be a composite index, it can be a multi-key index, but make sure that the fields that you're returning in your query should be in the same index. And finally, no fields in the query are equal to null. That is, field value should not be null. In such case, covered queries will not be followed. Now, before getting into the execution part, let us just consider a simple example on how covered queries works in MongoDB. So let's say I have a collection here which has 3 different documents of various customers like Rahul, Pranav and Kirti, and the orders that they have placed and the various personal details like address, their payment mode, email, order total, order items. We have an array field here wherein we are storing various fields in ordered items like item name, like notebook, paper, general or postcard, and even their price and the quantity of the items. So we have 3 different documents present in a collection here. Now, if I want to create a simple index, let's say I'm creating an index on orders item field, wherein I'm creating a particular index on the price here. So and also payment mode, I'm creating an index. So the query would be db.orders.createIndex, orders item.price. I'm mentioning one that is in ascending order. The index is created in ascending order. And also for payment mode, I'm creating an index. Now, generally, what you have to do is, what you do in general for indexing or while querying your data that is present in your collection is, you just mention the customer, or let's say if I'm trying to find the customer name here, that is Rahul. If I consider this example here, it says db.orders.find customer Rahul, orders item.price 1, payment code 1. Now, we are providing all the index field that we have created, that is orders item.price and payment code. But the query that I'm trying to find is the data of customer here, that is Rahul, which we have not indexed. So let's say I'm just having 3 documents here. Now, if there are, let's say, 10,000 documents that are present in collection, and maybe we have more than one Rahul, in such case, it becomes difficult, right? Even the indexes is become an anomaly here. It is not as fast as what we have thought here. Now, instead of that, I'm just taking another query. Now, let's say I have created index on orders item.price and payment mode, right? Now, what I'm doing is I'm trying to return the data, or I'm querying for data wherein I'm trying to find the payment mode is equals to card. Now, if you look at clearly into our index query that we have created, payment mode is already included in the query index, right? We have already created earlier, and I'm trying to find it in the same way. So I'm trying to find payment mode card, which is again already created index, which is payment mode. So in that case, instead of looking through all the data present in documents, it will simply look at only the ones which are already indexed. And that is the main advantage of covered queries. It returns results from an index directly without having to access any source document, and it can be more efficient, more than just indexing, right? So I hope you understood how covered queries are actually working in MongoDB. And let's just go into MongoDB shell now and get into the execution part and understand it in a more clear way. And also finally we'll analyze how this query is working and how it is different from indexing in MongoDB. So as you can see, MongoDB shell has started. So the first command would be is basically the show DBS, which will allow us to show all the database that are present in a MongoDB database. So we have the SimpliCode one database, so we'll be using that only. Right, use SimpliCode 1. So it says switch to DB. We are good to go. Now let us see the collections that are present in this database. So we have different collections like collection name, employee, marks, and new employees. So let us just consider a collection that we've already created here, which is employee. So let's just find the details or the documents that are present in this collection. So I'm using the v.employee.find command for that. So when you enter, it will display all the records or the documents that are present in this collection. Alright, now let us now create a covered query. Now creating a covered query is similar to that of how you create an index. So the query would be db.employee.create and mention the create index keyword. Make sure the I is capital, otherwise it will throw an error. So let's just create an covered index on the fields. Let's say we have manager ID and department ID, right? So we'll be creating covered query that is on this 2 fields. So mention the field name, that is manager ID, keep it as 1, comma, and department ID as well. Close the brackets. Alright, and click enter. So as you can see, it says manager ID _1, department _ID _1. That means you have successfully created covered query on these 2 fields, that is manager ID and department ID. So now let's query or read data from this covered index. So for that, we'll again use the find operation. So let's say I'm trying to find a particular manager ID details, right? So let's say I want to try find the details of employees whose manager ID is 123. In such case, I'll use a query that is db.employee employee dot find, and inside the brackets, let's say manager ID is 123 that I'm going to search for. Close the brackets and mention the indexes that you have created here, which is again manager ID, which is 1, comma, department ID, which is again 1 here. Close the brackets. I think we're good to go. So click on enter. So as you can see in the above query, when we find document where we are trying to find manager ID, which is 123, covered index, which is on manager ID as well as department ID, is already loaded into the RAM. And as we know that, manager ID is already present in our component index. That is why it reads very quickly and we avoid scanning of too many documents in database. So this is just a basic example on how to create a covered query. So let's just create a another field where we understand how covered query exactly works. Now let's say I'm trying to create an index on the first name. Let's say first name as well. So let's take the query as db.create index. I'm just copy pasting it here. And let us create another index for our collection for this. So it will be first name here. All right, first name, close the brackets. So as you can see, our query has been successfully created. Now let's say I'm trying to find the employee details using this index that you have created now. So I'll just let's say I'm trying to find an employee whose first name is Shelly. Now by default, since I've created index on manager ID as well as department ID, it will be directly indexed and display in our resultant set. So make sure you keep the first name field also, because we have created the index for that as well. So mention first name as 1, comma. All right, I think we are good to go now. Let's just see the result for this. So there was a bit error in the first time that we're trying to retrieve. Now Shelly, which we have taken her name in all caps, which is not exactly present in the same way in our collection. So make sure you keep the name as exactly which is present in our database, which is capital S, and the rest of them are small caps here. So when I try to find the resultant set for this, the final output is the first name, which is her name Shelly, and we are getting the manager ID as well as the department ID that she belongs to, which is manager ID is 101 and department ID is 110. Now if you look at this query, covered index will not be available when you use this following query, which is db.employee find first name, which is Shelly, and we are mentioning the indexes that we have created for first name, manager ID, department ID. Because when we find a document where first name is Shelly, which has covered index on basically the first name, manager ID and the department ID, which is already loaded into the RAM, but by default underscore ID is also present here. That is, the field that is not present in the covered index is also being displayed. So despite of manager ID, department ID present in our component index, we cannot avoid scanning of too many documents in our database. So we need to exclude underscore ID as well if you're trying to use covered index. So make sure you include underscore ID in your query as well. So the query now that would followed as, with the help of indexes that we have created, make sure with the first name keep the ID as 0, only then top. So I'm mentioning underscore ID after the department ID, keeping it as 0. So let us just find it now. So as you can see, we are only retrieving first name Shelly, manager ID and department ID, and finally underscore ID is being eliminated or dismissed from this. So that was all about covered index, guys. Now you have to remember that covered index does not work when field on which we're trying to cover in covered index is an array or an embedded document. That is, when you're trying to retrieve data from a subdocument or a field that is present in an array field, in such case, covered index won't work. So let us now try to understand how to analyze this query. Now the performance of indexing is very crucial for a database performance, right? So we need to understand how it is being executed, in the backend as well. So for that, we'll use the explain command here. So for that, the query is same, guys. Just copy paste the query that you have, created. And after that, mention the explain keyword, which is the explain command here. So there was a bit issue or error in the copying this code, guys. So I'm just copying paste the query that we have written here, which is db.employee.find first name Shelly, first name manager ID, department ID, and all the indexes that I've created on. And finally, you have to mention the explain command here. Now, analyzing queries is very important aspect of measuring how well or the effective the database and the indexing design is. So for that, I'm using the explain command here, which basically provides information on the query, indexes that you have used, the performance, that is the time that it has taken to execute your query, and other statistics. So it is very helpful when analyzing how well your indexes are optimized, while you are using an indexing or a covered query. So let's just see how it works here. Click on enter. So you can see it is displaying all the details of the performance or the optimization of the query that has taken place in the background here. So you can see we have various fields listed in all this here. You can see the namespace, index filter set as false, and all that. Now we are only concerned with here is this stage. Input stage is IX scan, that is index scan. The short form for this is index scan. So basically that we have performed a index scan on the query that we have created in our resultant set. So it basically says another condition where you'll find this is a collection scan, that is COLLS and scan. So you may find that is you're not providing any index, instead you're finding all the documents one by one simultaneously using a collection scan. That is another scenario in which we consider the type of scanning that we have done here. And you can also see that index name that we have created, that is first name, and it's multi-key, it's false, unique false, partial false, and so on. So it basically indicates the number of documents that have matched, that are returned here. It indicates the total number of documents that we have scanned, and indicates the total number of documents or index entities that we have scanned here. All this you can find using the explain operator here. And with that, we have come to the end of today's session, guys. I hope you all understood the concepts and the various topics that we have covered in today's session on covered queries, why it is used, when it should be used, and how it is different from, just indexing in MongoDB. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content, and if you want to learn more about MongoDB concepts, we have a dedicated playlist on our channel, so make sure you check that out. Until next time, stay safe and keep coding.